allow her to be loud. She's studying a lot. She's too little. All right, so let me start by checking a bit the assignments and where you are. By the way, this is our weekly plan. I decided to have a weekly plan, not for you, for the other sections basically, because I'm getting so confused between different sections, especially that Monday and Tuesday, they're not going along. So I thought probably do the same with you. So this is week 3, by the way. No, this is week 2. This is what we did week 2. Week 3, all right, that's the plan. I want us, and that's a tentative plan. Let me move this to the side a bit. So I want us to go over the old assignment because next time I gave you extra time, like I decided not to discuss it. I want to talk and answer some questions you have about the lab 1, and start lab 2. Lab 2 is actually long and a bit challenging. I'm so sorry for that, but let's take it being like a practice for us, okay? Also, I want to tell you something. A lot of students in your class are starting to ask for meetings because they're struggling here and there. Please, I want you to do the same, and I want you to ask for a meeting every time you need to, okay? Especially if you feel stuck somewhere, don't let it stay on you for a while, okay? So please let me know. I will definitely find a slot for us to sit and talk about any difficulty you're having. Yes, you were saying something? No. All right, now back to your assignments. Let me have a quick look with you to see where you are at the moment. I think this is your class. Yes. Yeah. So what does it say? It says that so far I'm still expecting Nagam to show her assignment, Muhammad and Leen. So you guys, I know that probably you were having difficulties, or probably you didn't know you need to submit the assignment.
Doctor,
Yes.
Leen has dropped the course.
Oh, that's true. That's true. All right.
Doctor, I didn't submit yet.
Guy? No, I'm talking
Yes.
assignment, not lab 1.
Okay.
Lab 1, as you can see, nobody is submitted yet. And I think this is good because the deadline is in the evening, right? If I'm not wrong. And it's good to take some time today to discuss your work before you submit. However, keep in mind that submission is unlimited. So if you ever submit and you want to change your mind, do so, okay? No problem. It's unlimited, like you can submit many times, because I want to keep room for in case you have questions, in case you want to modify something, okay? So let it be open. It's practice. Remember, this is practice for the final exam, practice for the midterm. All right. What about Nagam and Muhammad? Roy, I think it's 11 p.m. Okay, today. Anna is having connection issues. Thank you for informing me. Is Nagam with us or Muhammad? All right. Anyway, they're gonna speak up later. Now let me take our assignment. I think I can find it here. Assignment. I'm gonna open it and I'm gonna write on it. Okay, so let me open with preview so I can write freely on it. I want you, in case you have your answers in front of you, how about you fetch them quickly and you tell me what you got? All right. I don't want to correct the first one. It's so easy. If you want the answers, just count the digits that are underlined. Now for this one, anyone who would like to tell me what answers you've got, let me prepare your names next to me so it will be easier for me to communicate with you. Okay, let me just do this. Okay, and now to fetch the assignment again. Sorry for all the windows. I cannot be more organized. All right, I'm gonna put a text box in here. Okay, it's in here, and let's use it. Hussein, are you there? And let's do this quickly because we have a lot for today. Hussein is not here. Yara?
Yes, hello, doctor.
All right, Hussein, what was your answer for the length? And it's okay if you have mistakes, no problem. Just tell me what you believe, the measurement. I'm talking about the pencil and this actual ruler. What was the length you measured?
Yes, I'm opening my assignment right now. Just 1 second.
Of course. Just throw anything at me and fix it in a minute when it's open.
It's 4.25. I got it.
Okay, and then uncertainty units.
Plus or minus, yes, 0.25 centimeters.
So the error is 0.25 centimeters, and you just said centimeters. Let me add this here. Okay, let me correct now some mistakes you've got. First mistake is the error must be one significant figure. So 0.25 is not allowed. We need to round it to 0.2 centimeters. Why 0.2 and not 0.3? Because whenever we have 5, we follow the odd even rule, which states if what I have after the 5 or behind the 5 or whatever you want to call it is even, we keep. If it's odd, we round up. In case you say 0.3, it's not a big deal. Now the error is 1 decimal, so I need to round this to 1 decimal. I'm going to say 4.2 centimeters. Now, if any of you would say 4.2 or 4.3 or 4.4 even, it's not a big deal because you're still within the margin of error, okay? Let me know if you have questions. Thank you so much, Hussein. Yara, can we answer the next example?
Did I have a question?
Yes, of course. Go ahead.
Yeah, I had it down as since the balance is a digital device, so M is 126.4 plus or minus 0.1 kilograms.
All right, I totally agree. I want also to listen to Iman. Iman, you have a question, right?
Yes.
Yes, what was your question?
Uncertainty, actually, I calculated that was 0.05 only, not 0.2. Why it's 0.2?
All right, so
I divide 0.1 over 2.
Okay, so basically you have to take the smallest subdivision divided by 2. The smallest subdivision here is actually this guy. And this guy is half a 1, so it's 0.5. Half 0.5 is 0.25. You see it? So 0.25 is half the smallest subdivision. Be careful, sometimes we assume the smallest subdivision is something and it's not. And this is not a regular ruler, by the way. It's a different ruler. Do I make sense? Now back to Yara. Yara, I did the same mistake as yours. I did not see that this is LB. And it's actually not visible. So my bad. So which means I'm not going to write, how can I remove the pen? I'm not going to write kilogram. I'm going to write LB. Okay, but it's not a big deal because personally I did not see it as well. Any question for example number 2? Now, example number 3, probably ask Karen. Karen, what was your answer for example number 3?
I got 33.5.
Okay.
And the uncertainty is written, it's 0.5.
Okay. Any units involved?
Yes, Celsius. Degree Celsius.
Okay, so it's degree C and degree C, whatever you want to call it. All right. Let me check a bit. So this is 33 and this is 34. I have a feeling that 33.5 is okay to accept because it's okay to accept because you're still probably within the margin of error. But if I look very closely, it's very close to 33.0. So you are like on the margin of the error. You see what I mean?
Actually, in the assignment, I wrote 33, but I don't know what I said.
Okay.
Why I said 33.5.
Right. So I would say, okay, let's say somebody else would say 33.5. You took it so far, it's still okay, but let's try not to go there. So 33.0, 33.1, 0.2, 39, 32.9 is like more acceptable. Okay, but if you ever want to fight with your partner, I would say it's like on the margin of being acceptable. But yes, I got what you mean. So Karine, did we answer your question, I suppose? Yeah, we did. Okay, so now let me move to the next slide. Every time I try to be quick, I get so slow. So let's chill. We don't have the time to finish. It's okay, we finish later. All right, probably ask Karine. So I can see we have Karen and Karine. Yes. Karine, yes. What was your answer for T average if you did it?
I got 38.01.
Actually, it's 0.16666.
Okay, I'm gonna write it all and we can round it later. Okay. Okay. I feel horrible now that this text is going to the left. Okay, anyway. Yeah, and what did you get as uncertainty on it?
Doctor, I guess I forgot to do it.
All right.
I don't have a value for it.
It's okay. No problem. Let me fix something. I hate what's happening and I don't know how to fix it. This. Oh, it's fixed. I don't know. Anyway, so anybody probably ask Maria, do you have the RMS? Anyone has the RMS? Abdo, Roy, Anna, Genti?
Doctor, I think me.
Yes, Sherbel, go ahead.
يلا بس خليني افتح على الفيزيكس لاب اوكي لحظه.
لا يا شربل، لا كان لازم تفتحه من الساعة 10. هلا صرنا رح نخلص. So I can see on the chat that it's 0.07 degrees C. I have to accept it unless somebody can prove us wrong. I can see it's one significant figure, thumbs up. I can see it's 2 decimals, so I'm gonna fix that to 2 decimals if you allow me to. So this is 2.
مظبوط طلعت.
So you agree?
0.07.
All right, okay. Now Sherbel, stay with me. How about you find R for us? Okay? Like R in this case, let me move this to the side and
U equals
yes.
U est égal RE.
Can we please try English?
So,
yes. So R is U over I. Yes.
So R equal 159.84.
Okay, I guess this is easy for you, right? Because I'm checking my other section are finding a lot of difficulties, but you have more experience. Yes.
And the error on the R, we do the propagation of error. مرة بنعمل derivation على U مرة على I. So we got 5.
Okay, 5 ohms.
Yeah.
Okay, let me see if the others agree. And let me know if you don't agree. And now that I can see there's no decimals, I would want to round this one to
160
no decimals. So it's gonna be 160. How about I keep a point just in case, because 160 is 2 sig fig and 160 point is 3 sig figs. And this is more meaningful, I suppose. But in case you would want to write 160 without a dot, it's not a big deal. Yes, Karine, what is your question?
I wanted to ask, how many significant figures should the error be? The propagation.
Okay, any error, if it's error on one measurement, error on the average, error on the propagation of error, or error on the slope, it has to be 1 sig fig. Okay, we still have so this is the thing. All right, we have no assignments to do the error on the slope and so far and so on, probably because we did not cover them properly. Let me check. Data analysis 2. Let me open it and probably give you, if not, let's say you don't have time to do it, probably simply give you the answers. Okay, I never gave you a chance to do this alone. Now I got it. So this, okay. So the question here was, try this out, use Excel and your calculator. Okay, why Excel? This is, you were supposed to plot, right? You were not supposed to do the propagation of error because you are given a lot of points in here and a lot of points, right? Yeah, you did. So I'm sorry, Sherbel, I'm trying to remember what was the assignment about, because for other sections it was a bit different. So here we're supposed to find not U over I, but basically say that R is the slope. Is it actually the slope? If you take X to be the I, so let me say something. Plot U versus I. The slope is gonna be R, and then find the error on the slope. Okay, so now back to you. Yara, can you please help me?
Yes, of course.
Okay, so if you find the slope, did you do it on Excel? How did you find the slope?
I took the values, I plotted them in, and then I put in the option of having basically a linear function.
Okay.
So it filled it in on its own.
All right, so Yara used her calculator. Okay.
I looked in the options for it to put the equation on the graph, and the equation is y equals to 1787.3x plus 0.5736.
Okay, so you want to give me the equation of the whole thing, equation of the line. Can you say it again?
Yes, of course. It's 1787.3.
1700. Did you say 1787.3
yes.
x plus
0.5736. So we have the slope, which is the 1787.3.
All right, but the slope sounds wrong to me because, okay, did you use milliamperes or amperes? Nick Roy got exactly the same answer.
Amperes.
Okay, so does it say that R is 1700? If I take any random value for you and I, probably just to see the order of magnitude, so 2.2 divided by 1.5 to the power of -3, yeah, I will get something very close. All right. So, Sharbil, do you understand what you did as a mistake? So now I'm going to say the slope is actually 1787.3. I'm going to say ohms. I can say simply volt over amperes. And what error on the slope did you get, Yara?
I got 300 ohms.
300 ohms. Obviously, you did a certain rounding, which means this is the 1, the 10, and the hundreds digit, which means this cannot be as precise. I need to round to only the 100. So it will be like this. This is a tough example, all right? So if you don't like it, the best way is, all right, so 260 Jad and 260 Roy would be round up. Yeah, how do we round it? So basically 260 must be rounded to 1 sig fig, which is 300. Students have difficulties whenever we have something above 100. How do we round it? If you want, this usually can be written as 3 times 10 to the 2. And this looks a bit probably easier to see. Okay, let me put the font a bit smaller for it to fit because I'm all over this place. This slide is very ugly. And this one probably could be written as 1.8 times 10 to the 2. So if you believe you have difficulties looking at your values, when you write them, okay, did I do a mistake? Yeah, this is 18 times 10 to the 2. Yeah, when you look at your values in scientific notation or in a notation where you remove all the trailing zeros without the decimal and you put instead times 10 to a certain power, things will be easier for you. Okay, so if you round it to Yara, if you round it to 1787, it's as if you're saying 18 point, or it's as if you're saying 17.87. So if I write 17.87, look now at 17.87, look at the rounding, look at those two. The error has no decimals. And here you have 2 decimals that you should get rid of. So 8 is what is required. Okay, change your values to scientific notations or to any notations where you can get rid of your zeros, those trailing zeros that are not significant at all. So you will be able to focus on your digits. And if you believe this example is confusing or tough, don't worry, this is not very usual. It's like you're not gonna have this all the time. And if at some reason or at some point you don't know how to do it, let me know so I can help you, okay? So do you understand what we did? All right, because if I keep this as such, Anna, if I keep this as such, it's a lot of digits. When you look at an error of 300, 300 actually says that this is the fluctuating digit. Okay, this is the fluctuating digits, and those zeros are there just to tell you it's 100. Okay, so I have no information about the one, the ones, you know, the digit. I have no information about the tenth, and I have about the tens, and I only have information about the hundreds. So those two should be rounded to nothing. Like I should not have information over this one and over this one and over this one. This is really confusing for any student. I've been trying this with many students. The best way to convince them is to tell them the 300 must be written as 3 times 10 to the 2, and whatever value you have here, write it as something times 10 to the 2, then you do the rounding. Okay, so back to you, Anna. Do you understand why 17.87 should be rounded to less? If you look at this value and this error, do you understand why you should round this by removing the 2 decimals? Okay, so if you look at these two values, you would understand much better. Okay, so which means write it in terms of times 10 to the power of something of your choice. Usually the choice is related to something that would make your error look easier to understand, then do the rounding. Roy, ask me.
Yes, so doctor, why did we round 160.3 or 0.29 to 300?
Yeah, because
we didn't write 160.
Okay, this is a good question, by the way. 260 is two significant figures, and we agreed on the fact that all uncertainties cannot be more than one significant figure. So this is two significant figures. We simply round it to one sig fig. All right. Now the question is, why do we have to round the error to one sig fig? And that's a different issue. Roy, did I answer your question?
Yes, you did.
Okay. I did not understand in the beginning what we said about rounding when we have a 5. All right, this is a good question, by the way. Let me give you a quick example about it, Yara. All right, 2.45 will be rounded to 2.4. However, 2.35 must be rounded to 2.4. The reason is this 4 that I usually keep, it's even, so I keep it. And this is odd, I should round up to even. So statistics people were actually sitting together and they said that the 5 is in between. So shall I round up when I have a 5 or shall I keep it? And then they wanted to create a rule that makes it 50% round up and 50% not rounding up. So they voted for a rule that we call a conventional rule. And conventional rule means it's a rule that does not follow any reason, any rationale. It's like it's simply a rule that we follow, and it's an international rule. It's called the even odd rule. So every time you have a 5, you look for what is a digit before it, and if it's even, you keep it. Odd, you round up. And trust me, you will probably never ever have this example later on, so don't stress over it. It's nice if you know the rule, and if you don't know the rule, it's okay, you know, but it's nice to follow some international rules. And yeah, because it's, don't forget, you're getting introduced to data analysis. So this is how introductions are. Like, you learn new rules, sometimes you know how to follow them, sometimes you're convinced, sometimes not. In a different lab in the future, probably things would make more sense to you, you see. All right, so in the final slide they want the error, and we did it already. Fine. All right, I believe this assignment is very important. I have a feeling that probably 20% of the class is still silent, and they would want to ask. Probably they're too shy or feeling too behind to ask. I'm willing to sit with you privately, okay? So write a checklist, try to fill in your gaps, and meet with me so I can push you through each gap you have, okay? So this is not over, we can come back to it. I'm gonna close the assignment. I will post the solution that we just did together on Blackboard under data analysis. And now probably we can start with the following. Any question you have for lab 1? How was it going with you? Speak up. I'm gonna open for us the manual, okay? So manual. Yes, tell me. Are you ready to submit your work? Are you stuck somewhere? Do you need more time? Don't ask for more time because it's bad for you, because you will be overwhelmed.
Doctor,
Yes, Sherbel.
I have a question.
Okay.
في مطرح حطينا انه نرسم الالكتريك فيلد على الجراف. اوكي.
Okay. It's a sketch.
فينا نحط الالكتريك فيلد مش ضروري على الجراف.
What do you mean? تحت الجراف. All right. So what I expect to see? I expect to see, by the way, I want to see your sources. Try to guess which is positive, which is negative from the video. If you see, I showed you, did I? Yes, I wrote on the solution, the sources are position here. Did I? Yes, probably I did. So mark the sources and check on the video if the left is positive or negative, the right is positive or negative. Then I expect to see something like that as you join your points. And then they want you to draw the electric field. You say, by definition, the electric field should be perpendicular to the equipotential lines. So the red lines should be perpendicular to the blue lines. So you draw perpendicular, you draw perpendicular, you draw perpendicular, perpendicular, and you draw this. So I see, Sherbel, that it's so much easier to do it on your map, and probably easy to do it with a pencil or any drawing
device. I will tell you something. جربنا اول شيء بالبنسل نعمل هذه اللاينز نوصلهم ببعض تبع الالكتريك فيلد قبل ما نحط الشيل لاينز.
Yes.
اوكي. فينا مش نص ساعة، شي ساعة ونص تزبطوا معنا بالكيرفد اروز. جاء بالقلم كل ما نعملهم بيطلع هيك، عرفتي كيف يعني زيكزاك. جانا مش بدنا نعمل هدول.
The zigzag you're talking about. Listen, the zigzag you're talking about is something real happening on the bench. All right. So you cannot get a complete straight line. So بده يطلع لك value هون، value هون، value هون. وانت إذا بدك, what you can do is you can simply join them like this, or simply try to draw in between. Remember, this is an experiment. It's not theory. So the paper, by the way, the values given to you are real values measured by real students. Okay, our she students, so they have little experience in the thing. Two, we're talking about a real setup. Probably the paper given to them was wet, probably their hands were humid, probably the paper was poked. Don't expect to get beautiful straight lines. Beautiful straight lines actually translate a fake reality, right?
Doctor, you don't understand my قصدي.
Okay, what do you mean?
Okay, I told you انه بس يعني طلعنا هذا اللاينز هيك مثل ما محطوط. اوكي، هذا الزرق تبع الالكتريك فيلد.
Yes.
اوكي، سو after هن كانوا مثل بوينتس. نحن جربنا نوصل البوينتس على بعضهم اول شيء بالقلم، ما زبط، بيطلعوا كتير مزكزكين. فرجعنا قعدنا نص ساعة ونص نظبطها بالكيرفد اروز طلعوا مثل ما انت رسمتيهم بس طالعين مرتبين. عرفتي كيف علي؟
Yeah, ma, this is a map, and a map is something you need to create. And I need to tell you something, Sherbel. In the lab, this map only, not the red, the blue only, takes the students to measure and draw around 1 hour. And usually we ask them to do the map and leave and do the questions later. So you're lucky here, the coordinates are given to you. In real life, you need to find the coordinates, هيدا لوحدها بدها ساعة, and then draw the lines, you know? All right, Roy, no problem. But I assumed that the best way to find the electric field lines is to follow each blue line and hit perpendicular. You see? So هلا انت you draw the shape. Why not? You can simply write a text underneath to explain, and I've followed the fact that they should be perpendicular, and this is how a sketch would describe them. Whatever, okay? Fine. Remember, this is an open answer lab report, so any answer would be acceptable if it makes sense. Any other questions? Because I don't want to keep you for a long time unless you have issues.
جايين الشباب يعملوا الصبحية عندي، تفضلوا.
Sherbel, I want you please to stop the distractions, okay? This is an actual class and please get serious. Yeah, any other question? All right. If you remember anything you need to discuss, we can go back to this one, okay? Take some time today to finish your lab report. And if you need an extension, and you need to meet with me, we can do that, okay? My time today is full, but I think I'm gonna try to meet with a couple of students today. Now, back to our weekly plan. I know probably we need to go back to item 1 and 2. Let's try to target lab 2, capacitors and electric field mapping. I'm going to start with the theory and go through the experiment. Probably watch the video with you on fast forward and discuss the lab report, okay? This is an old presentation. I hope I did not miss anything. What does it say? Let me put your names away. And let me put the chats a bit far and probably my camera a bit far because my screen is never enough, even if it's huge. All right, that's our lab 2. It's a bit challenging, I know. And then I remember my physics 306 students are always tough students, students who would dig and research and try and study and ask. So I'm not worried about you. But I'm telling you, if you feel that this lab is challenging, don't be disappointed because not all the labs are as difficult, okay? And think about it in a positive way. Probably you can say this is your only chance to practice over those skills in data analysis. Like in this lab, you will be asked to do a plot on Excel. I'm sure everybody knows how to do this, but I'm also sure that probably you still have some gaps here and there, how to put a title, how to label the axis. So don't forget that, how to put units, a clear legend, how to do linear regression, how to write the equation. And I can, as I heard from probably Karine, who told me no, Yara probably, how she did the equation. You took the equation from the calculator, and you know for a fact that Excel is much faster. So let's use Excel, okay? If you want, actually. So you will be asked to find the slope. You will be asked to do the error on the slope. You will be asked to find a constant from the slope and the error on that constant through propagation. So it's a lot of work. And they will ask you to do propagation of errors on many occasions, like 3 times in one lab report, you know? All right, Yara, you used Excel. I misunderstood. And so on. So, and in this lab report, you have 4 parts to cover. Part number 1, 2, 3, and 4. 1 is the longest through data analysis. 2 is quick. 3 is okay quick. And 4 is also quick. So 1 is like a bit lengthy. Okay? So I'm gonna divide my presentation into 4 parts to simply explain what to expect in each part. The first part, you will be given exactly a very similar capacitor. It's made of 2 plates. Each plate is a disk, okay? 2 disks facing each other. The distance between the disks is a variable. So you can slide the disk on the track to vary the distance, okay? And what you have between the plates is air. I'm going to assume that the K, or the dielectric constant of air, is 1, which is basically not the case because it depends on humidity, depends on temperature, and so on. So I'm going to assume simply like it's very similar to the case where I have vacuum. Let me get ready with a pen, any pen of a certain thickness. Okay, so I'm going to use this equation. C is the capacitance of the capacitor. A is the area of one plate. It's basically the common area, and since they're facing each other, I'm going to take the whole area. And D is the distance between the plates, and this is the distance I'm talking about, or the distance I can measure. You will see from the video that I'm going to use a regular ruler to measure the distance between the plates. By the way, I'm going to measure from inside to inside, not from the outside, neither from the middle. It's a thick plate actually. And I'm going to connect this plate and this plate to something called an LCR meter that would measure either L or C or R. L is the inductance, we don't need it. C is the capacitance, we do need it. and R is the resistance. We're not gonna use it, okay? It's a very nice device, very precise. The capacitance we're targeting are very, very small. If I remember well, it's something nanofarad or picofarad. Can you imagine how small the resistance is? Like, you cannot do that with a regular multimeter, okay? And yes, the capacitance is very small. So the thing is, you're gonna measure C. Let me type it, insert a text box. So you're gonna measure C and you're gonna vary D, right? And then you're gonna plot C versus D. If you plot C versus D, do you believe it's gonna be a straight line? And let me move my slide to check your names again. Names. And slide. Allah, I can be really slow. Or probably just wanting to be faster every day. All right. So, yes. Iman, if we plot C versus D, do we get a straight line? Iman says no, says yes. Roy says no. Roy, please explain.
So C plotted against 1 over D would be linear.
All right, and probably Iman did not see it. Iman, C is equal to epsilon 0 A divided by D, okay? And since it's divided by D, D is in the denominator and you will end up having a hyperbola. Yes, I know the equation is not clear. So as Roy said, we'd rather plot C versus 1 over D. And we will get a linear relationship and we will find the slope. Now the question for Janti probably, what do you think the slope will represent? If you plot C, which is this guy, and let's say this is 1 versus 1 over D, the slope will be, yeah?
A times epsilon 0.
All right, so it's gonna be epsilon 0 times A. Can you remind me what is epsilon 0? The value of it, the theoretical value? You're glitching a lot.
It's a constant.
Can you type it? It is a constant, yeah. Anybody in class with us knows or remember from high school or from class how much epsilon 0 is? Epsilon 0 is the permittivity of free space, and its value is 8.85 times 10 to the negative 12 used with SI units, okay? Remember it? Yeah, so this is something you used to use in high school. I don't know if you remember. So that's the theoretical value. You will be asked to find the slope. And from the slope, you will be asked to find epsilon 0. Slope is known. A, the area is known. So you calculate epsilon 0 and you will get something very similar to this one. Let's say now you will not be able to get a value very similar to this one. The mistakes would be probably you've been dealing with units that are wrong. D, centimeter, millimeter, fix it. C, nanofarad, picofarad, fix it. And sometimes Excel will play tricks on you, because Excel would round your values when you don't want your values to be rounded. So if you're having difficulties getting epsilon 0 to be close to 8.85 and you have a mistake and not an experimental error, let me see if I can help you on any level, okay? So what else? All right, we have a trick in here, experimental trick that I need to discuss with you. What is the experimental trick? When you measure the capacitance of your capacitor, the LCR meter would measure the capacitance of the wires and the capacitor. So your job is to minus the capacitance of the wires. I'm gonna call them CW. CW is the capacitance of the wires disconnected from the capacitor. So I'm gonna measure this and you need to minus this answer from all your measurements. You see what I mean? This is very small actually. This value is very small, but it's not negligible anymore because C of your capacitor is also very small. So whatever measurement we do, the capacitance of the capacitor, we need to minus the capacitance of the wires, okay? That's part one, it's done. The idea is not tough. It's only that the data analysis is a bit time consuming. A is changing not at all. The area of the plate is gonna be constant. The only variable is actually D. All right, so Iman, when you measure the capacitance of your capacitor, the capacitor meter will measure the wires plus the capacitor. وانت you want the capacitance of the capacitor only. So I'm gonna remove the wires, put them on the desk, and measure the capacitance of the wires alone and minus them from all the other measurements. Yes, we're gonna subtract it. Okay, so I'm gonna give you the capacitance measured and the capacitance of the wires. Don't forget to minus it. I think it's written in the procedure in a very clear way. Okay, I'm gonna take my time, give you the results very clear because I want to make sure to include everything. So that's why I usually take until the evening to give you the results because I don't want to end up give you something missing. All right, now part 2, you will be dealing with the same exact capacitor, this one, but now you have to insert a dielectric. You will see in the video that I'm gonna put a piece of plastic, actually I'm gonna call it a sheet of plastic that is very thin, the thickness of which is 1 or 1.5 millimeters. Can you imagine how thick it is? It's like I have few papers like this thick. I'm gonna insert it inside the capacitor. I'm gonna close the capacitor on it. I will not compress a lot, neither too little. I want to make sure there's no air in between, no air in between, only the dielectric, okay? Now the equation is gonna be different. So this is without the dielectric. I'm gonna call it 0. C0 is the capacitance without the dielectric, and CD is the capacitance with the dielectric. All right? So I'm gonna insert the dielectric, do the measurements, then remove the dielectric slowly in such a way D is constant. I don't want D to vary. I want it to be a constant. So measure with dielectric and without the dielectric. And then to be able to find K, I'm gonna say it's simply CD over CO. Okay, because you see the area is constant, the distance between the plates is constant, so they cancel out. By doing CD over CO, you can find K. K has no unit, it's the dielectric constant. You're gonna try it for plastic and for cardboard. You will be given a piece of cardboard, like thick cardboard, put it between the plates and close, and you will see that the capacitance is gonna increase by a certain factor. You will be asked to find the error on K. Okay, by the way, how do you measure C? We use a digital measuring tool. So the uncertainty on C will be the smallest subdivision. It will not be given to you. You will see the values given to you and you will pick the smallest reading. So if I tell you 20.1 nanofarad, you say 0.1 nanofarad is the error. Okay, now I'm gonna ask Jad. Jad, how do you think we can find the error on K? Do you have an idea? Is Jad with us? If not, probably Aya can help. I'm sure Aya is with us. Roy, do you have your hands up? I did not see it.
It's from before, sorry.
Okay. So Aya probably cannot respond. Maria?
According to the uncertainty on the capacitance, so we will have like a range of values or only our the capacitance of the capacitor we are working with.
Okay,
so to calculate its certainty. Yeah.
Okay, I'm not sure I understood, but I will tell you in part 1, you will be given a table of different D distance and the C for each D, like a table of measurement C and D. And here we will only measure C without dielectric, C with dielectric, once for plastic and once for cardboard, only once. Okay, and if I misunderstood your question, Iman, type it for me, please. Propagation of error. Karine, speak up, please. Yes. How do you do the propagation of error for K? Can we do it to help up our friends?
So, no, you have to have the error of each one alone first, and then you do the partial derivatives of each.
So CO times alpha CO, okay, all of this is gonna be squared. Help me with the derivatives. I don't want to leave you today with a lot on your plate. So if I can help you with some hints that you can watch later or probably take notes. By the way, can you see the edits on the, you know, I'm writing on those slides, right? Can you see the edited part? Anybody open the slides? All right, anyway, if you open the slides and you don't see what's written, let me know. I can probably convert to PDF first. Yes, so back to you, Karin, help me out. How do we do derivative of K with respect to C0?
Minus CD over C0 squared.
Brilliant. Over CO squared. It is really obvious that you had a very good training in Physics 302. All right, and what about this one?
1 over CO.
Perfect. All right, so this is only to give some hints. Part 2 is really quick and easy. Now part 3 has nothing to do with the previous parts. All right, Iman, I will be with you in a moment. You will be given a box of capacitors, like a box where you have a lot of capacitors, and I'm gonna pick only 3. C1, C2, and C3. Now the connections are a big deal, and I don't know if it's good news or bad news, but I will do the connections for you because I need to give you the measurements. So I'm gonna connect C1 and C2 in parallel and find the value of C equivalent, measure it, and then put C1, C2, and C3 in parallel, measure the combination, and follow different combinations, okay? Your job is to do the calculation. Like, I'm gonna give you the nominal values. Let me type the meaning of nominal values, and I'm sure you know it's only, so I'm gonna give you the nominal values, and nominal values is simply what is written on a capacitor. I'm gonna give you the measured values for each capacitor. So I'm gonna measure each, because you know when it's written on it 300 nanofarad, sometimes it's 280, but they write it under, you know, it gives you the approximate value. So nominal values are never to be trusted. I will give you the measured value for each capacitor, and then I'm gonna put them in a certain combination, series, parallel, or any combination, and measure the value of the combination. All right, and I'm talking capacitance in here. Okay, your job is to do the calculation. Like if I give you C1 and I give you C2, do you know how to find C equivalent? If it's in series, you simply, for the capacitor, you do 1 over C equivalent to be 1 over C1 plus 1 over C2. If it's in parallel, C equivalent is C1 plus C2, and I hope you can remember those. And check, is the measured value close to the theoretical value you have, to the measured value and theoretical value. So your job is to be able to compare in here. So make sure you compare the measured value to the experimental, to the calculated value. Okay, fine. All right, so in the video, I'm gonna show you the different combinations. Now let me see, Iman, you mentioned that we are going to calculate the uncertainty of the capacitors. We have a table full of DNC. So the smallest value will be the uncertainty on the capacitance. Yes, and let me write it here as a hint. The capacitance is measured. So the capacitance is measured using a digital measuring tool. So the smallest reading is the uncertainty, okay? And let's keep it as such in case you want to use it later on. All right, now, all right, so Genti, all right. What about the uncertainties in part 3? In part 3, we will not do any uncertainty and any data analysis. The measured value, I'm gonna give you everything on the screen. In your case, you're gonna do the calculated value, and we're talking about calculation that are tough, 1 over C1, 1 over C2, and then the answer you need to add it to something. We're talking about random combinations. You just need to round to the least number of sig figs, okay? So no uncertainty and data analysis. Now, Genti, you will be given a box of capacitor. When you look at a capacitor, there's something written on it. It's written on it 300 nanofarad. This is called nominal value. If you take this capacitor and measure it, it's going to give you something close to 300 nanofarad, but probably a more precise answer. Because when they do those capacitors, they manufacture them in bulk. يعني بيقولوا كل هول 300 بس each of which could be 990, 290, 280, 299, around 300. And they tell you the margin of error is usually called the tolerance. They say it's 5%. So yeah, so is it the theoretical value? I don't want to call it theoretical, let's call it the reference. So you will be given the nominal and the measured. For me, the measured value is a better reference. If I only have those two, you know, in life, there's nothing called theory and experimental. In life, there's something called measurement 1 or value 1 and value 2, and I'm going to pick one to be the trusted value. Here you have measured, you have nominal, and sometimes you have calculated. So the question is, do you want to compare the measured to the nominal? Do you want to compare the theory, the calculated to the nominal? Do you want to compare the calculated to the measured? Sometimes they tell you, sometimes they don't. So you take your own reference. For me, the least trusted value is the nominal because it's one significant figure usually. Okay? How about I show you the lab report, because talking in blank like that could not be meaningful. And give me a second. All right, so let me show you what to expect. And this is also for Roy. Okay, so part 3, which is here, part C, nominal value is what's written on it. And then the measured value, I'm going to fill this table, C1, C2, C3. You cannot calculate C1 because it's alone. Then C1, C2 in parallel, I do the measurement, you do the calculation, and you round according to what values you have. Now, to do the calculations, do you use those values or those values? Since they don't tell you, it's up to you. But I say those are more to be trusted, like more accurate. I measured the value. I don't trust what's written on it. Okay? And then I measure this one, you calculate this one. Measure this one, you calculate this one. And then they say, compare the measured to the calculated. So you compare this one to this one. And by compare, we're supposedly need to find the percentage difference. Don't forget, every time they ask you to compare. Okay? Then they say, comment on the possible sources of errors. Give 3 sources of errors, pick the main one. Okay? When you say compare, do you mean accuracy or precision? Thank you for this question. I love it a lot, actually. And I'm sure you know a bit and you're confusing on so many levels. Every time, what just happened? Just a second. Okay. Every time they ask me to compare, so compare, you do, okay, compare, you do the percentage difference. And I assume everybody knows the percentage difference. So you do theoretical minus experimental over theoretical or over the reference you want times 100. Now, if the percentage difference is less than 5%, you say accurate. So usually we use compare to discuss accuracy and not precision. How do we discuss precision? Precision, you have to look for the uncertainty on a certain value. Probably the value is not accurate at all. I look for the uncertainty and I divide by the actual value times 100. If it's less than 2%, I say precise. All right? So when you compare 2 values, the theory with the experimental, or the experimental with any reference you want. If they are far above 5%, you say not accurate because the reference is for you the reality, the truth. Now for precision, you don't look for the true value. You take the measured value and you see how precise it is, how big the range of error. So you take the uncertainty, divide by the value to look for precision. Okay? Now Roy is asking, What's theoretical in here? The nominal? All right, since here they're basically asking you to compare measured to calculated. Which one do you take as a reference? The calculated. Nobody will ask you to look for the nominal. To be honest, we're not gonna look at the nominal values. The nominal values are only important. Why? Because you will be given a box full with 6 capacitors. So by simply writing which one, you would not lose them. You know, you will keep on, you will look at it and you will see I picked 4.7 microfarad بس حتى ما ضيعه. So what's written on it will never ever be used. I have a measuring device. I'm not gonna look at the nominal value. Okay? No, the measured and the calculated. No, I think the calculated value is the theoretical one. I'm gonna call it a reference because when you do when you measure C1 alone and C2 alone, yes, and you do the calculation and you will get an answer. Please, Iman, mute yourself, you're distracting me. So when you measure C1 and you measure C2 and you do the calculation, I can say there's less errors involved. But when you put all these capacitors together with a lot of wires involved, I think there's a lot of errors. So for me, the measured value in here, let me change the pen to a different color. Okay, the measured value, where's my pen? Where's my pen? Where's my pen? Okay, the measured value here is actually less accurate than the calculated value because there's a lot of wires involved and I trust this one more. So I usually take this one to be my reference. You see? Isn't the theoretical? All right, so it's measured and calculated. Divide by which one? We divide by the reference. And the reference is the calculated because usually it's more trusted in here. Okay, usually I take the reference, I will divide by the reference and I'm gonna take the reference, the one I trust more. For example, and it's okay, Iman, no problem. For example, in biology, they take the experimental to be the reference because they trust the experiment more than the theory. In physics lab, usually we take the theory to be the reference because we're only doing the experiment to validate the